Hi, I'm June, I'm a math tutor, and today is what the heck is a least common denominator? What the heck is a least common denominator? So let's say we're going to use bars today instead of pies to represent fractions. So let's say I break this whole into two pieces. Each piece is 1/2, right? So this is 1/2, and this is 1/2, right? And we know this because, make this bigger. We know this because the bottom number tells us how many pieces the whole was broken into. And you're referring to 1 of 2, and again 1 of 2 here, right? Well, let's say that I take the same bar, forgive me if it doesn't look like exactly the same bar, it's supposed to be, and I break it into 3 equal pieces, right? So pretend these are perfectly equal. So the denominator would be 3, and each individual one would be 1 of 3, okay? Now if I want to add this and this, visually it's very difficult. How the heck am I supposed to do that? So that's where a least common denominator comes in. What it means is, it's pretty straightforward. It means I'm going to cut this into smaller pieces, and I'm going to cut this into smaller pieces until each of them have the same number of equal size pieces. So this 1/2, so 1/2, I'm going to break each of the halves into 3 pieces, okay? And this 1/3, I'm going to break each of the thirds in half. And now each of these has 6 pieces. So if I want to add this much, which is half, to this much, which is a third, I can just add 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. So the 6 family, or the 6, where did I get that? And it's the least common denominator. Why? What makes 6 so special in this case? Well, let's go back to before we broke it up. Okay, now we have halves and thirds, right? Whatever number of equal boxes we're going to have in the halves, it's going to be 2 times something. Will tell us the number of equal boxes we're going to have when these are the same. And whatever number, and why will it be 2 times something? It's because I'm going to make these into a certain number of boxes each, so it's 2 times that number. For the thirds, it'll be 3 times something, right? So 3 times, remember before was 3 times 2, because I made each of these into 2 boxes. 3 times 2 is 6. 3 times 2 is 6. And then I made the halves into 3. 2 times 3 is 6. And that's how I got to 6, right? So we know it's 2 times something and 3 times something is the same number. Same number. Because we're looking for the same number so we can add them, so that you have the same number of boxes in both, right? So let's go back to halves again. And thirds again. What we do is we say, we know it's going to be 2 times something and 3 times something, and it's going to end up being the same number. It's got to be the same number. So we say 2, 4, 6, 8, etc. 9, 12, oops, sorry, skipped the most important one. 3, 6, 9, 12, okay, 9, right. So we look at our list and we say, what's the smallest number that's on both lists? Well, 2 is not on both lists, 3 is not on both lists, oh, 6 is on both lists. So what that says is, I can take 2 boxes and get to 6 boxes in equal, by dividing them into equal numbers. And I can do the same thing with 2. I can get to 6 here, and I can get to 6 here. So that's what a least common denominator is. It says I'm going to break these up into smaller pieces until the number of boxes is equal. I want to aim for the same number of boxes in each, and I don't want to have a lot of extra work, so I want the least number of extra boxes each, which in this case is 6. We could do 12 eventually, 8, 9, 10, 11, 12, 8, 9, 10, 12. 12 would also work. We could make 12, but that would be more work than doing 6. All right, so let's look at the process for changing things without boxes. Let's pretend we don't have boxes. 1/2, 1/3, and we know that they're not the same, so we're gonna 2, 4, 6, 3, 6, 9. We see that 6 is the least common denominator, and we convert them. So we say, how many times, 3 times what is 6? 3 times 2 is 6. 1 times 2 is 2. So 2 over 6, 2 over 6 is the same thing as 1 over 3. Oops, sorry. 1 over 3. 1 over 3. Okay? But more important is 3 times what is 6, and do the same thing to the top. Why do we do the same thing to the top as we do to the bottom? So that we maintain the same ratio of top to bottom. It's two sets of 1, and it's 2 sets of 3. So I keep getting sets of 1/3, 1/3, 1/3. As long as I multiply the top and the bottom by the same thing. 2 times 3 is 6. 1 times 3 is 3. And we have the same ratio, 3 out of 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. And we just keep getting sets of 1 over 2, 1 over 2, 1 over 2. I hope that's cleared up what the heck is a least common denominator. Least common denominator is the number of boxes that I can break 1/2 and 1/3 into, the same number for both. And it's the smallest number that I can do that with. Could it be just any number? Could it be 7? Like if this is 1/2 and this is 1/3, could it be 7? Well, let's see. If I break this in half and I break this in half, that gets me 1, 2, 3, 4. If I break this in thirds and I get this in thirds, that gives me 1, 2, 3, 4, 5, 6. If I break this in fourths, that'll be 8. So we skip over 7. So anything that's not a multiple of 2 won't work, right? Same thing with thirds. Anything that's not a multiple of 3 won't work. And that's why we do 2 and 3, and we find their multiples, and we find the one that's the common one, and the smallest one. I hope that's helpful. My name is June Wolfman. My email is jw418@columbia.edu. There we go. I'm a tutor. You need a tutor. Have your mom or dad call me. Alright, take care. I love least common denominators.